In part A, we need to find how far did the grapefruit drop from the tree and hit the ground 0.77 seconds later. So we use 1/2 times gravity times 0.77, and that is equal 2.9 meters. And in part B, the final velocity is 7.7.
Okay, now I'm gonna explain problem 2, stage 2. And it says an astronaut drops a rock on the surface of an asteroid. The rock is released from the rest at a height of 0.85 above the ground and hits the ground 1.44 seconds later. Given the change in position and the time it takes a rock to fall on the moon, acceleration is requested. We use the third kinematic equation. There we isolate acceleration, and the equation is left as acceleration equals displacement divided by time to the square divided by 0.5. The values are substituted and we are left with the resulting acceleration of. Okay, so I'm going to explain the problem number 3 and 4 of the stage 2 of Master in Physics. Number 3 talks us about vertical displacement and then free fall. The problem says you shoot an arrow into the air. 2 seconds later, the arrow has gone straight upward to a height of 30 meters above its launch point. So first, we're going to take out the vertical displacement, and then we're going to take the free fall by using the formulas of stage 2, which are final position, it's equal to initial position plus initial velocity times time plus 1/2 times acceleration times 2 to the square times time to the square. Okay, the first question that it asks us is what was the arrow's initial speed. I use the first formula, which is final velocity to the square is equal to initial velocity to the square plus 2 times acceleration times displacement, and it gives me 26.3 meters per second. Then part B, it says us how long did it take for the arrow to reach first a height of 16.5 meters above its launch point. I simplify the equation of final position is equal to initial position plus initial velocity times time plus 1/2 times acceleration times time to the square. And with that, I can take out the time, which is 0.725. Okay, then the next problem. Okay, next problem says that a cannonball is fired horizontally from the top of a cliff. The cannon is at a height of 80 meters, which is the initial position in y-x. And the ball is fired with initial horizontal speed, which is the initial velocity in x. Then it says assume acceleration due to gravity to be 9.80 meters per second squared. It asks us, given that the projectile lands at a distance of 2 meters from the cliff as shown, find the initial speed from the projectile. So to take out the initial speed, we have to use the projectile motion equations. I use the one of range, which says that initial velocity to the square divided by the gravity times the sine 2 times the angle, and it gives me 49.5 meters per second. Then part B, it says that it asks me that what is the position y of the cannonball when it is at the distance from d times d divided by 2 from the cliff. Then you can, if you need to, you can use the trajectory equation for this projectile, which is y is equal to h minus g times x to the square divided by 2 initial velocity in x to the square. And using this equation, you can take out the initial position if the y is at the middle of the total distance. So instead of 200 is 100 meters. So you substitute all the results you have, all the numbers you have, and it gives you 60 meters. And that will be all.
5 for stage 2. I use the formula y final is equal y initial plus velocity initial multiplied for time plus 1/2 gravity per time raised to. And I convert this formula to form minus y initial is equal 1/2 per minus gravity per time. First, I can obtain the time. For this, I use a formula. Time is equal distance over velocity. And this is time is equal 1.96 over 4.83. That this is equal 0.40. And then I use a formula minus y initial is equal 1/2 per minus 9.8 per 0.40, and I obtain 0.80.
Problem 6. Then, as we can see there, part A asks us for after a package is dropped from the plane, how long will it take for it to reach sea level from the time it is dropped? Assume that the package, like the plane, has an initial velocity of 342 kilometers per hour in the horizontal direction. In the problem, in the blue part, we can also see that it has an altitude of 725 meters, and that also gravitational acceleration or just acceleration will be 9.8. And it is asking us for time, so we can use this formula that is final position in y is equal to initial position in y plus initial velocity in y times time plus 1/2 times acceleration and this will be 0 because it is going to be on the island, so the final position in y will be 0, and initial velocity in y is also 0, so this will be 0 too. And now searching for t, we are going to be able to get a square root of 2 times the height will be equal to the time, and this will be 2 times 725 over 9.8, and this will give us as a result 12.6 16, or rounded, it will be 12.2. And this is part A. Now part B. Part B says, if the package is to land right on the island, at what horizontal distance from the plane to the island should the package be released? Okay, for this we're going to use this formula, that is the final position in x, that is what it's asking us, is equal to initial position in x plus initial velocity in x times time. We know that this will be 0, and so we will have initial velocity that it's important to mention that it is in kilometers per hour, and it cannot be on kilometers per hour. It has to be in meters per second, and making the conversion, we got that is 95 meters per second. So we will have 95, that is the initial velocity in x, times the time that, as we got in the part 8, is 12.2. So making this multiplication, we will get 1,159. So, and that is the answer that is right there. Part C. Part C is asking us of what is the speed of the package when it hits the ground. For this, we need to know two things: the final velocity in y and the initial velocity in x. We know the initial velocity in x, that is 95, but we don't know the final velocity in y. So we're going to get it by using this formula right here. We know that this is 0, as we say before in part A. So this will be gravitation, acceleration times time. So it will be 9.8 times 12.2. And this will give us as a result that final velocity in y is equal to 119.56. Now, with this, we are able to make this calculation to get the final velocity. 95, that is the initial velocity in x, plus final velocity in y, also to the square, and this will give us as a result 152.7. That is the answer that we see in part C. Now part D is asking us that the speed at which the package hits the ground is really fast. If the package hits the ground at such a speed, it can be crushed and also cause some serious damage on the ground. Which of the following will help to decrease the speed with which the package hits the ground? It is decrease the plane's speed and height. This is because at less height, gravitational force will have less time to act on the object, so acceleration will be less. So you can know that it will help to not make so many damage on the ground.
To problem 8. In this problem, they ask for the maximum range, which will be obtained with the formula of speed squared between gravity and all that by sine of the angle. But that angle will be multiplied by 2. That is, here it will be 13.5 squared between gravity. The result is 18.6 meters. Note, the angle is not used because the largest range is 45 degrees, and putting it in this formula gives 1, so nothing changes.
Okay, now with problem 9, we have that it says a projectile is launched with an initial speed of 12 meters per second, and at its highest point, its speed is 6 meters per second. What was the launch angle of the projectile? And this can be simply done by using this a formula that is inverse cosine of 6 over 12, and we will get 60 degrees as a result.
Stage 2, problem 10. Problem 10 asks for initial velocity. We take the one in J with the y in Y with gravity by 2, which will give 19.62. That is going to be divided by the 32 of the velocity in X, and with that you get 31.5 degrees. That is the answer of the part B. From the part A, the speeds come from the square root of the sum of what is in the X and the Y velocity, which we raise to the square. 10 times 9.8 equals 80.80.